10 choose 1, yes, okay, and times success 1/6 just one time, and that means what? Failure probability is 5/6. That one occurs 9 times. So this is how you can set up. Okay. So once you compute, it's going to be 0.323. Next one is getting no more than 3 6s. No more than 3 6s. So what does that mean? Probability that x is, well, that means x could be 0, 1, 2. What about 3? Is it 3 allowed? Yes, because no more than 3 is not allowed. So x is less than or equal to 3. Okay? And remember that the calculator is set up one way. That is always from x equals 0 to the number you want. Okay? Calculator is always from there. So this means 0, 1, 2, 3. So it fits the calculator setting. Okay? So binom CDF. This time is a CDF. Again, 10, comma, 1/6, comma, 3. Okay? So that gives you 0.930. Okay. This time, getting at least 5 6s. At least 5 6s. So that means x equals 5, 6, 7, ... 10. Correct? So let's look at this. 5, let's look at everything. 6, 7, 8, 9, 10. What you are interested in over here is this. Can you use a calculator directly? Well, not so, because the calculator is set always from 0, x equals 0. So what do we have to do? We are going to the entire case, okay? Entire case from here to the end is probability of 1, correct? So 1 minus of these case. The complementary case is going to be x equals from 0 to 4. So you can say 1 minus probability that x is less than or equal to 4. Get that? Okay? So that gives you 1 minus of this gives you 0.015. Yeah, at least 5 6s. That is, a lot of 6s are occurring. That has a very small chance. Okay, it's a very small chance of 0.015. Okay. So I think by now you could thoroughly understand what to subtract. Okay. The next one is very similar to this problem. I'm going to just set up. This time, you go to a meeting, and that is a meeting for the marketing personnel, okay? Approximately 75% of marketing personnel are extroverts. That's interesting. 75%. Well, 3 out of 4 are extroverts, yes. At a meeting of 10 marketing personnel, so n equals 10. First of all, is this a binomial probability experiment? Well, you go to a meeting and you ask, they are all marketing personnel. Do you think you are extrovert? Well, yes or no. Only 2 cases, right? Yes or no. and the 75% of chance saying yes. So this is what it's saying. So P equals 0.75, therefore 1 minus P equals 0.25. Okay? So let's set up A. What is the probability that exactly 4, so P equals, let's go to this. Well, if you do it by hand, okay, I'm going to just setting up here, 10 choose 4 times 0.75 to the 4th power, and exactly 4. So 6 people said, no, I'm not extrovert. So this is what that means. Okay? And B, what is the probability that at most 5 of them are extrovert? Okay, at most 5. So that means x equals 0. 1, 2, 3, 4, 5. Correct? So you can say binom CDF. 10 people over there. Probability P is 0.75. The large number over here is the number. The cutting right end is 5. So that is 0.9976. It's almost 100%. Okay? At most 5 of them say, oh, I'm extrovert. Okay. Part C, what is the probability that at least 6 of them are extrovert? So part C is at least 6. So what do you think is going on over here? At least 6. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least 6 is this. Therefore, in order to use a calculator setting, you are going to subtract this portion from 1. Is that correct? And we already calculate that. So these two are at most 5 and at least 6. They are complementary. So in order to do this, x is at least, so greater than or y equal to 6 is 1 minus 0.9976. So that gives you 0.0024. Okay? So that's how you compute. Okay, I did that on briefly. So now go for the new one, number 5. Well, given that probability that event E occurs is 0.7, given that probability F occurs is 0.6, and the probability that E and F occur is 0.42. Alright? Okay. So the first thing is, are E and F disjoint? Disjoint, what does that mean? Well, we can say E and F, there is nothing in common. Nothing in common is, well, look at the given information. The third piece over here is P probability of E and F occur. That means simultaneously occur is 0.42. So that means there is overlap. Okay? There is an overlap and this portion is 0.042. That's what that means. So answer is no. They are not disjoint. Okay? Disjoint means this, but the third condition says this. Therefore, answer is no. Okay? No other things that give us a clue. The next one is B. Find the probability that E given F. Okay? E given F. So what does that mean? By definition, this is a probability that E and F occur divided by given F. F has taken place. So divide by that probability. Okay? This is by definition, so what is that? That is 0.42 divided by 0.7. Well, that is 0.6. The last question is interesting. Are the event E and F independent? This is not a problem about this joint. This is independent. Do not go with your just perception, okay? You may get a wrong answer or because of a wrong perception. So what you have to do is we are going to use this. If probability that E is the same as probability that E given F, okay? So E just by itself, this one E occurs given F has occurred. Okay, if these are equal, then we may say we will say E and F are independent. So look at that. Probability that event E occurs over here is 0.7. And E given F. Oh, I made a mistake over here. This point is here is F is 0.6. Therefore, this is 0.7. I'm sorry, okay? Yeah. Earlier in part B, there was a mistake. I put this wrong number, so answer is 0.7. Over here is answer is also 0.7 because we calculate over here. Yes, they are equal to 0.7. Therefore, what is the answer? It says E and F are independent. So that means event E and F, they do not influence each other for their probabilities. Okay. Sorry about that, okay? Part B, make a correction for that. And for the exam, yes, the exam will be set up on my STA lab, and as you do homework, and yes, I selected the practice homework problems, right? Okay, and that one, computer says it takes about 50 minutes. Well, I give you enough time over 50, so I'm going to set up as a 75 minutes as we do have in-class exam, all right? So, the problems will be very simple, okay? Of course, when I put it on the paper, we have the same type, but the settings will be a little different. But when you do today's homework problems, then you are going to see, okay, the questions in the exam will look like that, okay? Of course, these contents are the same as we do in this paper. Number 6. Well, this one is data represent the political party by age group. So Republican and the Democrat. And the age group 17 to 29, 30 to 44, and the 45 to 64, and the 65 plus, and the total. Okay? So here we go. A voter is randomly selected from the sample. So we do not know the age group, we do not know their political affiliation over here. And we are going to compute the probability. Okay. First, I want you to write down the fraction and round to 2 decimal places. The randomly selected individual or voter is Republican and the age of 65. So Republican and, yeah, it's very important, age of 65 or older. So where are these voters located over here? Republican, and therefore this is going to be this cell, correct? Okay, so that is 561. The total voters they did in the sample is 4,000. Therefore, the probability of this is going to be 561 over 4,000. That is roughly 0.14. Okay? Part B. The selected individual is in the age group of 17 to 29, given that the person is a Democrat. Okay, look. So we are going to look at only Democrats. Among that, what is the voter is in between this age group, 17 to 29. Therefore, we do not look at those Republicans, right? Because the given condition is the voter is a Democrat. So you go to the Democrat, the total is 1,800 is a total. Therefore, you are going to say 1,800 out of this. How many are in this group? That is 184. Okay, so 184 over 1,800. Do not use 4,000 because this time is already Democrat is known for that. Okay, so that is roughly 0.10. The next one is give any two events that are disjoint. Well, this is the easiest problem you can find, right? Disjoint group. So I would say the Republicans and the Democrats. Yeah. So first row and the second row, yeah, these are disjoint. Yeah, so Republicans and the Democrats. Or if you use age group, well, 17 to 29, well, the separate one, 30 to 44. They are completely separated, so you may say that. Okay, so you can find many examples over here. Okay. We call this kind of a table two-way table or contingent table. Number 7 is the following data represent the number of speeding tickets individuals received in the past 12 months. So X over here is the number of speeding tickets. Have you gotten one? Well, here those ticket values, okay, the number of tickets, X. Here is 0, 1, 2, 3. And the frequency, each individual said, no, I never got a ticket, speeding ticket. That is 169 people said that. I got one speeding ticket, 21 people said that. I got 2 speeding tickets, 4 of them. It's pretty bad. I got 3 of them. Well, there are still 4 people who got 3 speeding tickets in the past 12 months. Okay. Well, from here, can you compute the probability? What do we need in order to compute the probability? Probability is the same as what? A relative frequency. So we need a fraction. Yes, we are going to compute the total of this frequency, which is 198. So that's what I gave in the bottom, the sum. Well, over here is you set up 0 out of 169, therefore 0. Oh, I'm sorry, not 169, 198. The next one is going to be 21 out of 198, that is 0.11. The next one is 0.02, and the next one also 0.02. When you add up this, not 0, I'm sorry. Here frequency is 169. Oh, something was not quite right over here. That is 0.85. I'm sorry. Here frequency, relative frequency is a frequency 169 divided by 198. So add them up, of course, you are going to see that that one is exactly 1. Okay, so we completed the table. Find the mean of the random variable x. What is a random variable x? Well, yeah, you can compute sigma x times p of x. So compute what? Compute this 0 and the probability over here and this, that. Okay. you may do that. You get 0.21. On the other hand, the second problem makes you think like, well, do I want to by hand or do I want to use a calculator over here? There is a typo. Find the standard deviation. Yes, part B. Part C is standard deviation. So variation is a wrong one. So this is a variation. I'm sorry, I don't know where it came from. Okay, so standard deviation. It makes you think like, well, I want to use a calculator. So do you remember how to use a calculator for that? Okay? I didn't even give a formula for this. Okay? I expect you to use just a calculator. So in order to do that, you are going to make a list. Okay? Go to stat and list. So make this one as L1 and this frequency as L2, not the probability. Yes. L1 and L2 and go to stat, go to calculate, C-A-L-K, C-A-L-C, calculate, and this one is one step variable. We use 2 for regression analysis only, okay? So one step. So when you do that, this one is a standard deviation of this sample, not the population. So we are going to look for S of x, not this one, okay? Because you are looking at the sample. So what do you have? That one is going to be 0.57. So in short, how do you understand this? The mean of this, the random variable, the number of speeding tickets, well, that one is 0.21. So what does that mean? Well, individually, yes, this is expected value, same as you expect a ticket, well, 0.2 ticket per year. That's how you understand, okay? So sooner or later you are going to get one. That's what it suggests actually. Yes. And let's go for number 8. Yes, number 8. Well, I didn't do exact problem like this in class, so I want you to pay attention to this. But I chose this problem because you are going to really appreciate why they said is expected value for the mean, okay? A life insurance company sells 200,000, just 1 year life term, okay? 1 year term life insurance policy, okay? So this is for 1 year term for not any age group, yeah, 20-year-old female, 20-year-old female for $300. In other words, let's say I'm 20 years old, okay? I would be very happy. I'm 20 again.